sabab this network should be very strong because every people are using there. Which network you all use? I'm using Geo Fiber. You people are using which one?
So I don't know my Wi-Fi.
Geo Fiber is very good. Airtel Fiber, all optical fiber wala is good. If it is cable wala, it is not that strong. 36. Geo Fiber is very good. A thin mica sheet of thickness 2 into 10 raised to minus 6 meter and refractive index 1.5 is introduced in the path of one of the interfering beam. Wavelength is 5000 angstrom. Then the central bright will shift to. Now if you remember, formula I had given, shift in fringes mu minus 1 into T by lambda. So 1.5 minus 1 into 2 into 10 raised to minus 6 upon 5 into 10 raised to minus 7. So 0.5 into 2 into 10 raised to 1 upon 5. 10 raised to plus 1. Okay. 0.5 into 2 is 1. So it will be 10 upon 5 equals to 2. 2. A option.
Yes.
37. In a biprism experiment, the micrometer eyepiece mounted on a stand on optical bench is used to measure what? That eyepiece is used to measure distance between. See, in a biprism experiment, eyepiece is used to measure what? Wavelength of light, separation between virtual source and fringe width, separation between virtual source and fringe width, distance of screen, only the separation between magnified images of virtual net. Hello? This is micrometer eyepiece where there are cross wire. We try to find fringe width with the help of this micrometer scale. So separation between magnified images of virtual or separation between virtual source and fringe width. Distance of screen from slit. Wavelength of light. In a biprism experiment, use eyepieces mounted for what? In eyepiece, we see the interference pattern. So it is used to calculate wavelength. Huh? Hello? So actually this is, there are 4 stands. Hello?
Yes.
This optical bench wala now it is deleted, even if you omit this will do. But it is used to measure wavelength. 38. In Young's double slit experiment, the angular width of fringe formed on the screen is 1. Theta is angular fringe width is fringe width upon capital D. That is lambda d upon d into capital D. 1 degree you have to convert into radian by multiplying with 5.180 equals to d by lambda upon small d. Small d is 0.1 millimeter that is 10 raised to minus 5 meter. So 3 into approximately 60. So 10 raised to minus 5 upon 60. 100 upon 60 into 10 raised to minus 7 you get that. So that is nothing but 5 upon 3 into 10 raised to minus 7. So this will be 1.66 into 10 raised to minus 7, close to that. 1.66 into 10 raised to minus 7 meter, which is same as 0.166 into 10 raised to minus 6 meter. That means 0.166 micrometer, which is in close agreement with A. See, this is 1.6 because I took pi as 3, so slightly greater than this.
Yes, sir.
59. When two when light from two coherent sources of same amplitude and wavelength illuminate the screen, the intensity of central maxima is I naught. What will be the intensity at the same point if the sources are incoherent but the same amplitude and intensity? Incoherent. See, if it is incoherent, that means they are not in same phase. Hello?
Yes, sir.
If sources are incoherent, then phase difference is 90 degree general. So resultant intensity will be I plus 2 root I cos of 90. That will become 2 times I of individual. And central maxima before is 4 times I. So I resultant upon I central is 2I upon 4I. That will become 2. Therefore, I resultant, I central is given I naught upon 2. So which have the same magnitude. The intensity of central maxima is I naught. What will be the intensity at same point if the sources are incoherent but same amplitude and intensity? Incoherent. The resultant was correct. 4I 0 by 2. Sources same amplitude, same wavelength. Intensity of central maxima is 4 times I0. What will be intensity at same point if sources are going to this half of 4? See, there is again printing error. It should be I not by 6, I not by 2, I not by 4, and I not. This is correct answer. I not by 2. I not by 2 is the answer when it is incoherent. Because the resultant becomes 2I. 2I means twice of individual. That means half of I maximum. In Young's, a screen is placed 90 centimeter away. A screen is placed 90 centimeter away from luminous object. Okay, 90 centimeter away from object. The image of object on the screen is formed by convex lens at two different positions, separated by 30. What is focal length of the lens? Focal length of the lens is how much? 90 centimeter away. Focal length is separated. One distance is 30, other is 90. 60. The image of object on the screen is formed by convex lens at two different positions separated by 30. At two different positions separated by 30. These positions are separated by 30. So if this is at A, two positions separated by 30. If I call this as B, this distance is formed by that. Yes, yes. Screen is placed at 90 centimeter. 40th weight, huh? 40th weight. In double slit experiment, intensity at a point where path difference is lambda by 6 is I. If I naught is maximum intensity, I naught is maximum, then what is I upon I naught? Okay. See, I naught is maximum means it is 4 times I. 4 times original. Original I am calling as I dash. Now, path difference is lambda by 6. So, what will be phase difference? Can you tell? 2 pi by 6. Right? Phase difference is 2 pi by 6. Phase difference 2 pi by 6.
Yes, sir.
So, pi by 3, that means 60 degree. So, resultant intensity I is I dash plus I dash plus 2 root I dash into cos 60. That means I is 2I dash plus 2I cos 60 is half. 2 to cancel. So I is 3I dash. Therefore, I upon I naught is 3I dash upon 4I dash 3 by 4. 3 by 4. D option. Completed? Is completed? Okay. 42. The ratio of amplitude is 4 by 3. Then maxima to minima. Maxima to minima is A1 plus A2 upon A1 minus A2, which is 4 plus 3 minus 4 minus 3 square. This is I maxima to I minima. So it will be 7 upon 1 square, which is 49 upon 1. That is option C. 43. Light of wavelength 5500 falls normally on a slit having width of 11 into 10 raised to minus 7, and Fraunhofer diffraction is received on the screen. What is the angular position, that means theta, for first minima? For first minima, d sine theta is 1 lambda. So sine theta will be lambda, which is 5500 into 10 raised to minus 10 in meter upon 11 into 10 raised to minus 7. So this will become 11 into 5 is 500, 55. So 500 into 10 raised to minus 3, which is 0.5. Therefore, sine theta equals to half. Theta equals to 30 degree. Option 44. Okay, please copy this one.
Yes.
44 and 25. Two sources of light P and Q has wavelength of 6000 angstrom and 5500 angstrom respectively. In a biprism experiment, first the source P is used and then it is replaced by Q. It is found that position of nth bright corresponding to P, position of nth bright, is occupied by n plus 1 bright of Q. Of Q means second color. This is first color. Then what is value of n? Same sum we have done many times in numericals. So this is n1 lambda 1 is n plus 1 lambda 2. N1 n into 6000 equals to n plus 1 5005. Two zeros cancel. I can cancel by 5. 12n 11 into n plus 1. So 12n is 11n plus 11. Therefore n equal to 11. Option 45. A light of wavelength lambda is incident on single slit, width a, distance t from slit. In diffraction pattern, width of central maxima is equal to width of slit. Then what is it? Width of central maxima is 2 lambda d by t, and that is same as t, is 2 lambda d by t. 1 d cancel. Therefore, capital D is 2 lambda. Capital D for myself is equal to width of slit, and t should be d by t. Capital D comes out. So it will become D equals to D square upon 2 lambda. D square upon 2 lambda is option C. Okay. So we have completed all. Once I have to do that one, I will check.